acceptable. I have to remind you, we are compressing it, there will be a little bit drop in quality. It should not be speed. No, speed is operation is not. It's just about the knowledge, because we are rounding the numbers in the precision of the model. But I would say, for high value use cases, for the use cases where you really need to take the maximum out of a model, you want to write some code that has not been written before, like this. So for those high value use cases, go with the full precision, go with the latest, best models on the market. If you have to push the boundaries, there is the high volume. For the high volume use cases, go with the quantized models, go with the scale economy, go with the cheaper to run. Because sometimes we have to do the first task as a breakthrough, and sometimes you just need to do a lot of repeatable tasks that are nothing very special. So different use cases, different models, choice is important. That's why we want to think that you should be able to mix and match. I'm not saying that one, if it was that promise, then you would say never use the full precision, always go with the quantized because it provides those. But there's always a trade-off. So we have to be able to validate these trade-offs and make the best choice for our implementation. Because I'm doing exactly that in my environment. If I can go, I'm downloading models, I show you that. So in my environment, I'm having these two. One is the full precision FP16. So this one is coming directly from the Mistral factory. And the other one is the quantized one coming from the Red Hat factory. Each one of them is in my registry. I can put all kinds of data in my registry. And from my registry, I can also go and look at the models deployed. So in my environment, I'm having currently, as you have seen, I have three models. I have this Granite, and I have this Mistral Full and Mistral Quantized. Mistral Full is running on 4 second. Different GPUs, but this one is full, is running on 4 GPUs, other one is running on 1 GPU. And that is quite 4 times less resources, 4 times less consumption, while almost the same performance. But you should not trust me on that, because you need to test everything. I told you, we need to test. We need to have a little bit luck, a lot of experimentation, a lot of testing. So with the pipeline that I'm creating, for every model that I deploy, that I introduce in my pipeline, I'm also having the model testing and the benchmark pipelines. So for example, here is a pipeline that for every model, I run evaluation and I run a benchmark. And those are the 2 different tests. So evaluation is going to evaluate the quality of the responses of my model. So you are hearing about new model is being released, and it is the leader, it is scoring so much on this benchmark, that much on that benchmark. So these benchmarks are evaluation benchmarks. They evaluate, for example, how good the model is in reasoning, how good model is in understanding mathematics, how good model is in understanding coding, how good the model is in understanding multiple languages. There are tens and hundreds even different of these evaluation tasks that each new model is being evaluated or tested against. So I also want to use these evaluations on testing my models. So I'm using the same evaluation task to run the full precision model and the quantized model. And I'm running only the tasks that are relevant for my use case as well, because sometimes you are preparing a model that needs to be a code assistant. So in that case, it's better to understand how his understanding of code, of Java, of Python is. than necessarily understanding Dutch, Chinese, or Bosnian language, right? In some cases, you want to have it as a chat assistant. In that case, he's not going to write code, but he needs to be able to reply to the human questions, to do some reasoning, to be good in ABC, multiple choice, and different evaluations that you want to apply. But I say, every model ran, and that's what my LM evaluation does, and it gives me score of both models so I can start comparing. And I can say, okay, this quantized model is using 4 times less resources, but is still acceptable, the percentage on these evaluations? I still have the same quality of the responses. One set of evaluations. Second set of evaluations is this.
Are you creating those evaluations yourself, or is this something that is a commodity within the industry?
Both. Both. So, eLooter is the project that is coming from Google, and this is a project that has most of the currently used evaluation tests from the Hugging phase. So if you want to say, I want to use the benchmark, generic benchmark that are being used by other models, you start with eLooter, and you get the tasks from here. And there's a whole list of tasks. I can share you that later, but these are out-of-the-box evaluations. But they're not going to be enough, because once for example, I say this is a good model, it has good reasoning, it has good understanding of the language, and I have now taught him about who is Salman and who is Ahmed company. So I want to have now evaluation to test that knowledge. So I can also take one of these existing evaluation tests, and I can rewrite it for my own tests. So that's how I would say. You start always with the defaults, with the ones off the shelf, and then you start building your specific evaluations, because you are building specific agent with some specific capabilities. So you would also like to test that things that you have baked into the model to this evaluation step. Does it make sense?
Yeah.
It's,
so my question that I then have is, for mathematics, it's quite easy because it's either right or wrong. But can you also have the evaluation that it's more interpretation of what you think is right or wrong? But the model might have a different opinion. Maybe different people have different opinion of what's right or wrong. How do you evaluate that?
I don't know. I sit with other smart people and we think together.
Yeah.
We will probably take an existing evaluation that is close to what we want to achieve, and then we will do the reverse engineering and try to make it fit our use cases. But it is difficult.
Yeah.
And evolving, the things are new. There are new standards popping up almost every week, every month. So say it's fun, and surround yourself with smart people. That's my only advice. But this is one of the frameworks, just to explain. So I want to explain the 2 types, but then it's also benchmarking. Because I deploy this model, next question is, how many users can use this? How many concurrent prompts can I send to this? When is the breaking point of this model? So then you want to use something like the benchmarking, and we provide, as part of the VLLM, which is the runtime, we also provide tools called Guide LLM, nothing special, that is able to run different benchmarks and test your model. I was very unfortunate to not having the good test results here with me, because something changed during the last couple of days, and now it's not splitting all the metrics here. But I had a very nice here dashboard where I'm looking, I'm monitoring 2 models. One is using 1 GPU, other one is using 4 GPUs. Then you look at the memory usage, and then I look also, I stress that here with the tokens per second. And I created a load test that aids 5 concurrent users every step. So I start with 5 concurrent, 10 concurrent, 15, 20, 25, until I'm looking for a point of breaking. So the point of breaking is I'm looking at here, time to first token, for example. We have the different timing. Time to first token is that time for the first response, and then after the first response, there is a time between the tokens that is continuing that. Tokens per second. So I'm adding more and more and more users until I see that this time to first token goes up, meaning he's broken, he's not able to reply immediately. As long as this parameter is in milliseconds, I can increase the load, and to be honest, 25 users is the breaking point for both of the models. They work on the 20 concurrent users, one on one GPU, other one needs 4 GPUs, and around between 20 and 25 concurrent users, it starts breaking, it starts showing. You have to trust me that this has been working in the past before. But it is good that, because this should be familiar tools. I'm using Grafana, I'm using Prometheus, I'm using all the tools that we are already using for any other monitoring. So you can be surrounded with smart people. If you have people that are already using these metrics, for them it's no-brainer monitoring an LLM. So I want to say that consistency is also important. If we would introduce a new technology, a new platform for this, and then have to learn each component, it aids complexity and the cognitive load through the process. But here are numbers of different dashboards. I created this one for my comparison with VLLM. We provide these already out of the box dashboards that you just loaded in the Grafana, and the data is broken because I had to change my image because I broke environment, basically. And then, again, the model registry is also becoming a crucial factor. So we said we don't want to make the Wild West. We don't want to go and randomly download any model from the internet. We want to enable a government and a centralized hub, and that's where this model registry that I previously showed you could play a crucial role as a central hub for model versioning, collaboration, one-click deployments, and so forth. And this is probably the star of the show. So this is the VLLM inference servers. This technology is honestly what puts really Red Hat on the map of AI. VLLM has become de facto standard for running large language models on your infrastructure of choice. In the beginning, we had a couple of different flavors of inference servers. Now I think that the VLLM and NVIDIA are the only two ones, while VLLM is the one with the fully open source that supports all the hardware. So it supports NVIDIA, but also AMD, Intel. It's supported on all the clouds and all the vendors, and it is becoming de facto standard. The Red Hat has acquired a company called Neural Magic, and that's how we got this technology. It's fully open source. We are the lead contributor, but it's also contributed by all the other companies. So NVIDIA is contributor, Google is contributor, and so forth and so forth. What makes this VLLM super special and why it really won the race of this inference server, it is his way that it managed the resources. And to manage the resources, especially when it comes to the caching and the memory usage of these GPUs. So with the way that it's used, it fills the cache, the large language model uses the cache for the context, the way that it is able to fill the cache and stream the data, it makes it utilize the resources best on the market, and simply no easy alternative currently. It is fully open source, and it is powering OpenShift. But if you say, hey, I don't need OpenShift, I just need inference server. Don't bother me with all these tools, platform. I just need a server to run large language models. VLLM is also a standalone product. So you can get it as a container image from Red Hat, and you can deploy it on any container host. It can be a vanilla Kubernetes, it can be a Ubuntu, SUSE, Linux with a Docker on top of it, and you will have an inference server for running your large language models. This is a bit unique from Red Hat because usually we only provide support if the technology is fully owned from the Red Hat stack, but because this is such a crucial piece of technology for enabling large language models in enterprises on-premise, we are giving it in this setup. So we are very flexible in this part. And apart from being able to run all these models on top of all this hardware, it also comes with this set of compression tools that you can use to quantize or compress the models that you have built, but you can also go to the Hugging Face of Red Hat and get the models that are already compressed by Red Hat using this tool. And model service, that's also capability. So how do I protect models and how do I expose them? This is something from the initial demo that I showed you, a catalog where we can go find the model, get the access to it, get the key, and start consuming it while getting the metrics. So in the beginning, in early stages of this development, we use 3Scale as an API management component. But we thought 3Scale is an overkill and an extra product in the landscape. That's why we went for that late MAS that I demoed in the beginning as a light API management for the large language models and OpenShift. Makes sense, or am I confusing you?
Makes sense.
Perfect. You are not falling to sleep. No?
But I thought it would be, you would have like you would use our laptops when there was like a insurance company use case.
I can give you that.
Yeah, that's what I thought I was misunderstanding. I also thought there was a hands-on workshop.
We had it last time, the previous session, we had a hands-on workshop.
Yeah.
I have that workshop available. I can give you after this. It is fully scripted. You don't need to hear me